Been here before. Fascinating man. He always has very interesting things. We've learned about hydrogen. We've learned about ballistics and electricity. Tonight, ladies and gentlemen, we will have some fun with circular motion. A professor of physics at NYU. Please welcome Dr. Richard Brandt. Hi, Doctor. How are you? Fine. Circular motion. What is it? What do we care about it? And what are we going to do with it?
We're going to spin today. We're going to look at systems that are spinning and investigate their properties and applications.
What are their applications? Because when I heard this, frankly, I said to myself, oh, we're apparently at the bottom of the barrel.
No, it's about the middle, I would say.
Middle? Oh!
Yeah.
What are the applications?
Well, there are vast applications to sports and to space flight and to ballistics again, and in fact, even to the Earth. The Earth is a spinning system, and it has many consequences of that we experience every day.
Now, how does the Earth spin? Can you just quickly explain that? It's on, show us.
Right, well, it's spinning around the sun, as you know, and on its axis, but more interestingly, it's actually rotating about an axis due to the torques exerted by the moon and the sun, and that rotation takes, I think, something like 25,800 years to complete. And when that's completed, then we're back where we started. But after 12,900 years, it'll be summer in January, you see, because the axis will have rotated like that. It's just like a big top. Mm-hmm. So you see how practical spin is?
So this is the middle of the barrel.
Yes.
Okay. All right, you've brought some fascinating things for us to take a look at.
Let's start here.
All right.
One of the most fascinating properties of spinning systems is called conservation of angular momentum. Now, what that means is that if the radius of a spinning system gets smaller, it has to speed up, because the product of the radius and the speed is a constant.
Now, does it speed up because there is less resistance?
No, nothing to do with that. It's just a conservation law. It speeds up because it must, because of this conservation law.
I know an example of this. Ice skaters, when they pull themselves in, they spin faster.
Exactly. Actually, later in the show, after the commercial, you'll be doing that. No, before the commercial. You'll be doing that. But right now, we'll have the dumbbells do it. You won't be on ice. You won't be on ice.
Okay. All right.
All right. Here's our first system. It's going to rotate slowly, and then you'll just squeeze it together, and it'll speed up. And now if you unrelease it, it'll slow down.
Unrelease it?
Yeah, just let it go.
Just release it. Unrelease. You don't need to say unrelease it. We're just releasing it.
Okay, you got me.
Unrelease. This man is a professor. Is it a doctor? He has a doctorate in physics? Unrelease it.
I'll get you on the chair for this. So.
All right.
All right, that's good.
I kind of like that, though, isn't it? All right, doctor.
Okay, now, that's one property of the rotating system. Another related one is if the direction of spin changes, then...
Excuse me, let me re-button my coat.
When you take the chair, you'll have to unbutton it. Okay. If the direction of spin changes in one way, then another part of the system must change spin direction in another way to compensate. You just can't make spin. If part of the spin is made in one direction, another part must move in the opposite direction.
All right, this is a reaction.
Yeah, it's related to that.
Okay.
Now, we have a bicycle wheel here, which will set spinning, and we'll have to come around to the front here. And we'll get to these weights later. And you hold the wheel by the axles. Both.
All right.
Okay. And I'll wind this around. This should have been done.
Now, of course, if I get my tie caught in this, I'm a dead man.
Right. All right. I'll pay it. I'll pay it. Okay. Now, you're going to hold it, and I'm going to pull it hard this way. And just keep it steady, and we'll get it as fast as we can. Ready? Hold it. No, don't move. Yeah. Okay, good. Now sit on the chair and put your legs on the bar there. Now turn it horizontally. Horizontally. Okay, now nothing happens. Now turn it the other way. And as you see, you rotate in the opposite direction. Now turn it back. Right.
Whoa! That's great. You know, that's a really handy thing to have.
Yeah. I figure...
Let me reach over there and answer the phone. Will you hand me the bicycle wheel?
You can have a
That's
race.
very
you can have a
impressive.
race with Paul next week on this.
But that's very impressive because it's just, well, I don't know. You explained it, but
Right, but you got it. You understood
you
it.
can, as you turn it, you can actually feel yourself. Well,
Yeah, you can feel the forces.
Yeah.
It's the angular analog of the momentum experiment we did on the chair before.
Angular analog
of the momentum experiment, the linear momentum. Remember?
We have to move right along.
We have to move right along. Okay.
But that was a good one.
Let's sit on the chair again and go back to the spin. And now's where I get even. You're going to hold these two weights out, just like the ice skater. And I'm going to... No, it's better the other. Yeah, like that. Hold them out. And I'm going to spin you. And then you're going to rapidly, as you dare, bring them in, and you'll speed up a lot.
Right.
This is going to be great. Okay, slowly. Now bring it in. Bring it in. Bring it in.
Oh,
there you go.
yeah.
There you go. Oh. Now out. And just slow down.
Oh, yeah, that's unbelievably.
Yeah, you really feel the forces there,
Yeah,
and you see how hard it is to be an ice skater or a diver or a gymnast because they're turning like
there must
that.
be a way to compensate for that dizziness that you get.
Experience, I
I
suspect.
guess so. Okay, well, I tell you what, Doctor, we need to do a commercial, and then we'll be right back. I'm sorry about
Almost no one has every symptom of a cold. You may have a but not a or a but not a or even a but no sign of
That's why Triaminic products come in 4 formulas recommended by doctors and pharmacists for just the symptoms you have, so you don't take more medicine than you need. Triaminic in liquids and tablets.
why treat a and when all you want is a simple
There's a style in your life no one could ever deny. You're on your way to the top, and along the way you've always known just who you are. Where you're going, you've always known it. Where you're going, it's Michelob.
Where you're going, it's exceptionally smooth Michelob.
Where you're going, it's Michelob.
People who sleep on a waterbed city waterbed sleep better than you do. We're so sure of that, we guarantee it in writing. You see, the mattress you sleep on now creates pressure points on your body, and that causes you to toss and turn. A waterbed city waterbed contours and supports your body naturally. No pressure points, no tossing and turning. It's the most comfortable way to sleep. And when you sleep better, it's written all over your face.
If you are injured in an automobile or any type of accident, you have a simple choice. You can wonder about your rights to compensation for pain and suffering, lost time at work, medical and other expenses, or you can talk to Cohen & Cohen. 24 hours daily in Broward County, call 921-4700, and in Dade only, 532-1771 for your free phone consultation. Learn if you may be due a cash settlement or court award at no cost to you.
All right. Circular motion. I'm still dizzy from that, by the way. We have 2 more things to show here.
Yes. Okay, we're done with the theory, and now we go to the applications.
All
We
right.
have no gymnast here, but I have my cat, Jim Davis, the official cat handler of the NYU Physics Department.
Hi, Jim. How are you?
How you doing?
This is actually your cat,
My cat.
Richard?
This is Tobis. My
Hi,
cat.
Tobis.
She's
How
a
are you?
little old.
Nice to see you.
Yeah, right.
She's
going to demonstrate some gymnastics by falling on her feet when I hold her up and drop her, and then we'll explain why. Now, cats aren't very helpful.
Now, this is true. If a cat...
I'll get her. This is all rehearsed.
You need some pliers there, Richard?
Tobis. Okay, here we go. Okay, Tobis.
All right. Oh, my.
She likes
Poor
it.
baby.
Okay. Ready? Drum roll. Here we go. Okay. Thank you very much.
But now, again, if you should be very careful about doing that with your animal.
Oh, of course, I am very careful.
No,
Actually,
I know, but people at home just don't, you know.
No, I can understand. I love this cat very much, and my
Okay.
dog loves her.
Now, what are we looking at in the
Okay,
replay?
right. Let's look at it in slow motion to see how it happened.
All right.
Okay. Now, you see, the point is this. Here I have a model cat. This was made in... This was made in 20 minutes this afternoon by Howard Goldman from NYU
An
Physics.
advanced studies project,
Right.
apparently.
If you drop the cat like this, it can't just rotate this way, because remember we learned that a spinning system has to rotate in both directions. So what the cat does is bend upwards like this, and one part rotates this way, and then the other part rotates, and then it unrotates.
And that's what the cat did.
And that's what the cat did, and maybe we have time for an instant replay in slow motion again
Well,
to
let's
see
find
it.
out.
Watch
There
how
it
it
is.
rotates one half at a time. There's the top half, and then the bottom half next.
Yeah, no kidding.
Angular momentum conservation.
All right, Doctor, we're out of time. Please come back again.
I will.
From
I will.
NYU, ladies and gentlemen, Dr. Richard Brandt. Thank you, Doctor. Oh, watch your kitty. We'll be back with Richard Lewis after station identification.